Children, last class we understood what is capacitor and what is capacitance. Today we are going to understand the important derivations of capacitor which are frequently asked in board paper. So we come to the simplest capacitor, that is parallel plate capacitor. Parallel plate capacitor is a device which stores electrical energy in the electric field confined between the two parallel plates which are oppositely charged and placed parallel to each other. Now parallel plate capacitors are actually combination of two plates which are placed in parallel to each other, and when we charge this capacitor by connecting it with a battery, the two plates are connected with the two terminals of a battery. Now let us assume that this plate is connected with positive terminal and this plate is connected with negative terminal. Then actually what happens? With a positive plate of the battery takes electron from this plate and transfers them to this plate. So what happens? This plate starts becoming negatively charged and the plate which is connected with the positive terminal starts becoming positive charge. Now interesting thing is that the whole positive charge of parallel plate capacitor will lie on this surface only, which is facing the negative plate, and whole negative charge will lie on this surface only, which is facing the positive plate only, because of the attraction force between each other. So they are kind of bound charges which lie on the inner surface of the two plates. This is very important to understand, because then only we can calculate correct electric field inside the capacitor. So there is no charge over this surface and this surface, which are the outer surfaces of the capacitor. So when we charge a capacitor, we connect the plates with the battery terminals, and the plate which is connected with positive terminal becomes positively charged, and plate which is connected with negative terminal becomes negatively charged with equal and opposite charge. So now when we show this three-dimensional arrangement on paper, then actually this edge which I marked with the red color, this edge we show like this. So this side is actually this surface and opposite side is this surface. So understand what you see in the diagram. You observe in the diagram this edge like positive plate edge and this edge like negative plate edge. So now let us start the very first important derivation, that is what is capacitance formula for parallel plate capacitor arrangement. So first we should write this important fact that both the charges will reside at the inner surface of the parallel plate capacitors plates. And now we start with the derivation. Since only the one layer of charge is here and one layer of charge is here, so electric field at any point in between the plates is due to one layer of positive charge away from the positive charge and one layer of negative charge towards the negative charge. Now observe, electric field due to positive charge and electric field due to negative charge are in same direction. Therefore, the net electric field or resultant electric field will be sum of these two fields. So we will write that electric field in between the plates is electric field due to positive charge plus electric field due to negative charge. Now write electric field due to positive charge layer, that is sigma upon 2 epsilon naught, where sigma is surface charge density. That means the charge on the surface divided by area of the surface. Similarly, for negative charge also the electric field will be sigma upon 2 epsilon naught. So the total will be sigma upon epsilon naught. But we know that electric field can be written as potential difference between these two plates divided by distance between these two plates is equal to sigma upon epsilon naught. Now write sigma as charge on the plate upon area of the plate. So we are having finally this formula, and now we very easily can calculate capacitance, because capacitance is charge on inner surface of positive plate. Listen to me carefully. Capacitance of parallel plate capacitor is charge on inner surface of positive plate divided by potential difference between the two plates. So Q upon V will be epsilon naught A upon D. So capacitance of parallel plate capacitor is epsilon naught A upon D. Now we will observe this expression carefully. Here, area and distance between the two plates are very clear, but this quantity, which is permittivity of free space, actually this quantity is representing medium between the two plates. When air is in between the two plates, then this is epsilon naught, that is permittivity of free space. But if we fill a glass or mica or some poor conductor in between the two plates, then this term will be replaced with permittivity of medium in place of permittivity of free space. Now, a very important question: how can we increase capacitance of a capacitor? Or what factors affect the capacitance? So we will observe these three quantities and then we will answer. To increase capacitance, we should increase area of the plates, we should decrease distance between the two plates, and we should fill some material in between the two plates which have higher permittivity than air. A permittivity of air is 8.85 into 10 to the power minus 12 Coulomb square upon Newton meter square. So we fill a material which is poor conductor and having higher relative permittivity, and that way this term increases and capacitance increases. So the third way is that a poor conductor, which is called dielectric, is filled between plates. Permittivity of free space epsilon naught is always less than permittivity of that medium, and permittivity of medium divided by permittivity of free space. This is very important quantity called relative permittivity or dielectric constant. Dielectric constant is 1 for air, and it is always greater than 1 for any other insulator, and it is infinite for conducting material. So that way we can increase through these three factors. Changing these three factors, we can increase capacitance of a capacitor. And here we should write that Q is the charge on the inner surface of positive plate, which should be replaced here when we need to put the value of Q. In the next video, we will go through the second important derivation, that is energy stored in the capacitor, and all the videos which are related with the capacitor, I will give link in the description box. You can go through the capacitor topic in sequence in the playlist with the name Capacitor, Class 12. Also, all my these handwritten notes are available on my Telegram channel, and you can go and download the PDF of these notes.